Yesterday we talked about the 5 rules of probability. The first one being that all probabilities have to be between 0 and 1. The second one being that if I add up the sample space of a probability model, it should equal exactly 1. We talked about how to calculate a probability. You take the number of outcomes divided by the total number of outcomes. And then we talked about mutually exclusive events and how to calculate their probabilities. We said we could just add them up. But what is a mutually exclusive event? They cannot happen at the same time. All right? 2 mutually exclusive events cannot happen at the same time. And so we need to talk about, well, what happens if they do? So to do that, we're going to talk about gender and ear piercing. It's fine. So, raise your hand if you are a girl that has their ear pierced at least once. Okay? Raise your hand if you are a boy that has your ear pierced. Okay. Raise your hand if you are a girl that does not have her ears pierced.
They closed, so.
Alrighty. Well, there you go. So, does it appear that your gender and your ear pierced status has something to do with each other?
Yes. It doesn't.
Okay. Well, we're going to figure all that out. So, students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on 2 variables, gender and whether a student have their ear pierced, for 178 people in the class. Here's the 2-way table. I want to ask you guys a few questions, see if you can get the answers. Here we go. You ready? How many males were in the class?
Like 19, like 103. It was 98.
All right, so let me try again. How many males were in the class? 90. How many people in the class had their ears pierced?
103.
Okay. How many males in the class had their ears pierced? And how many total people were in the class? Very good. So what we're going to do, guys, is we're going to use that information. We're going to calculate some probabilities. We're going to define event A is that the person is a male student. Event B is that they have their ears pierced. All right? So we want to find the probability of A. What am I asking you to find here?
The probability of A.
Which is the probability of what? Male. This is right here. I'm just asking you the probability of a randomly selected student being a male in this particular class. So, what is the probability of a randomly chosen student being male? 90 out of 178. Okay, cool. Can anybody tell me what 90 out of 178 is as a decimal?
It's a little under
0.505. Perfect. All right, over here. I want you to find the probability of B. Now, what am I asking you to find?
The probability of B.
The probability of what? That the student has their ear pierced. Okay? This is the probability the student has their ears pierced. So, how are you going to find that one? 103 over 178. And what is that? 0.578. Perfect. Now, here we go. Find the probability of A and B. Tell me in words what I'm asking you.
Add them together.
Nope. Nope.
Probability of male.
Very good, Hannah. I'm asking you to find the probability that they are male and have their ear pierced. Probability of male and they have their ear pierced. What is that? 19 over 178. Very good. What is 19 over 178?
It's like
All right. And now, this is from yesterday-ish. Find the probability of A or or B? What am I asking you here? I'm asking you for the union. Yes, good. So what I am asking you for here is the probability of A union B. Now, yesterday, how did we do this? We did the probability of A plus the probability of B. And that was all we had to do. So if I do that, I would get the probability of A, which is 90 over 178. And I would add the probability of B, which was 103 over 178. And what do you get when you add those together?
75. Or 178 minus 75. 179.
You get a problem is what you get, ladies and gentlemen. Because I then would have 193 over 178.
That wouldn't work.
Why does that not work?
Because they do correlate.
These do not work because I am trying to use the mutual exclusive rule for two things that are not mutually exclusive. How do I know that being a male and having your ears pierced is not mutually exclusive? Because 19 of these overlapped. So being male and having your ears pierced do overlap. They can happen at the same time. And in this class, they did happen at the same time 19 out of 178 times. So guys, what happened here? When we looked at the probability of male, we were looking in that column. We were including the guys in this column, yes? When we were looking at the probability of having the ears pierced, we were looking at this row. What do you guys notice? I have overlapped, and that means that I have counted these 19 guys twice.
And you can't do that.
I counted them in the male section and I counted them in the ear pierce section. So how can I fix this? I'm going to subtract one of the 19s. All right, so if I subtract the 19 out of 178, because again, they were included in both of these, so I'm going to take it out one time, then I would get the actual answer, which is 174 out of 178.
So in theory, I was correct. But I said 178.
Yeah. Do you guys see any other way I could have gotten to that answer? Subtract the 4.
That's what I did.
Subtract the only people that were not included in this particular example, which were the girls that don't have their ears pierced. Okay? Very good. All right, you guys, is it or is it or?
What?
Exactly. All right. Have you guys ever been to Whataburger?
Yeah.
Sure you have. Let's say you go to Whataburger for lunch and you get a double meat Whataburger with cheese, no pickles, of course. And the cashier smiles and says, would you like French fries or onion rings? What are they asking you to do? Make a choice of one or the other. Okay? They want you to make a choice. Now, can you get both in that situation? You could, but you'd have to pay extra. You'd have to pay like for a side of the other one, right? Now, let's think about going to Starbucks. I'm sure you've been to Starbucks. So you go to Wob for lunch and then you decide to get a little pick-me-up at Starbucks and you order a cup of their house blend, which can be a little bitter at times. So the barista asks you, would you like cream or sugar? What can you answer? You could say, I just want cream. You could say, I just want sugar. Or you could say you want both. And it won't cost you anything to do that. Which or are we going to use in stats? Are we going to talk about one or the other, but we're never talking about both? Or are we talking about that it could be both? Very good. We are going to use the Starbucks or, okay? When we ask for a probability of A or B, we are asking, what's the probability of A only, B only, or both? Okay? That's what we're asking. So I just want you guys to make sure you're clear on that. We are always asking about the both. Okay? All right. So let's look at a Venn diagram. Do you guys know how to make a Venn diagram? Are you sure? So I'm going to show you guys how to make a Venn diagram statistically speaking. Here we go. This is the same example. We still have A, is that you're male. B, is that you have your ears pierced. Okay? We're going to let A be the circle on the left. This is A. Are you with me? We're going to let B be the circle on the right. Are you with me? Okay. Can you label the parts of the circles? So A is on the left, B is on the right, A is being male, B is having ears pierced. Can you put the numbers in where they go? Give it a try. Go.
The totals are all over.
All right, does anybody think they have it done correctly? All right, check this out, you guys. Here's what I saw. Don't write this down if you haven't already. I saw a lot of this. 90, 19, and 80, no, 103, sorry. And then you guys put 103. Here's why that's wrong. You guys, if I look at the whole circle A, the whole circle A should be the males. This whole circle should add up to 90. But right now it adds up to 109. What you doing? So, what should you have in this section right here? 71. That should be 71. Why? Because 19 of those 90 males are in the middle here and share this other section. And so we have to take off the 19 from the total of 90. Okay. All right. So, same thing on the pierced ear. The total pierced ear circle should be 103. The total pierced ear circle should be 103. So what should this section actually be? This should actually just be the 84. Now, have I used all of the numbers from the two-way table? No, which number is missing? From the two-way table, I'm missing the 4. Where does it go? It does go somewhere. It goes outside of both circles. So right here. That's not illegal. It's still within the sample space, which is the rectangle. Now, I'm going to show you guys how to properly notate them. Yes, so there's not a box. You can't do that, right? I mean, you can as long as you label it, but I mean, technically you should draw a box to show the sample space, but some people don't draw a box. They just write it outside the circles. But all right, I'm going to show you guys how to properly notate each of these sections. So I'm going to erase this so I have room there. Okay, cool. Here we go. I'm going to move that 19 down. By the way, when you guys are making your Venn diagrams, a little pro tip for you, always start your labeling on the innermost circles where they overlap and then go out from there because you have to subtract out as you go. All right, here we are. In the middle, we have D and, I'm sorry, not D. What am I? I'm already thinking ahead. A and B. Did you guys see how I just made that and? It looks like a little rainbow. It's an upside down union. And this is called the intersection. And when you see it, you should say the word and. So this is A intersect B, also known as A and B. This is where A and B occur. Alrighty. Tell me in words what's going on with these 71 people right here. Those are males that do not have their ears pierced. So these are A, but not B. So this would be A and B complement. This is A and B complement. So they are in the A circle and they are not in the B circle. All right, what is the 84? How would you notate that? A complement and B. I forgot my complement. Whoops. A complement and B. There we go. And what about these four? A complement and B complement. These four right here are A complement and B complement. That is how you label a Venn diagram statistically speaking. Why are we uhing? Yikes. Huh?
No.
Are we stressed? If we're too blessed to be stressed, come on. We got this. All right. Now, here's the deal. Yes, because it is not in the A circle and it's not in the B circle. All right, so here it is. What is A or B from our A or B? Now, there are several ways you can do this, you guys. There are several ways that you can do this. So the first way is we can do this the Starbucks method. We can say A only plus B only plus both. So cream, sugar, both. Okay? So we could just add up those three numbers. Okay? And that would work. So we can do the 71 over 178, the 84 over the 178, and the 19 over the 178. We can do that. We will literally get the same thing we got just a few minutes ago, which is 174 over 178. Or we can do what we did a minute ago. We can add the whole A circle of 90 over 178 plus the whole B circle. Oops, that should be an 8. And then subtract that overlap of 19 that we've counted twice. We could do that as well, okay? So there's several ways you can do this problem. You get the same answer every time. You can also take 1 and subtract the 4 over 178. You can do that too. Ladies and gentlemen, there are going to be multiple ways to answer all of these problems. You get to decide which way works best for you. Cool? Cool. So I want to show you guys another picture. So check out this picture. Where is the intersection of these two events?
Just like in the middle.
In the middle, okay? So this is the, right here, this is the intersection. That's the and. Okay. Now, where is the or? Where is the or located? Outside. Nope. The A or B is located right here. You ready? Watch this. Let me see if I can get it. It is all of that. That's the or. It is the middle circle as well. It's everything except what is outside of both circles. That is the or, okay? That is the union. The union is everything in both circles. Now, how you decide to add all that up is up to you. You could even do the A circle and then the B only part. You could do that. You could literally do this so many different ways. All right, you guys, the general addition rule for two events. If A and B are any two events, regardless of if they are mutually exclusive or not, then the probability of A or B is the probability of A plus the probability of B minus the probability of the overlap that gets counted twice. Can you guys do me a favor and remind me of something? If A and B are mutually exclusive, what is the probability of A and B occurring at the same time?
0.
A big fat 0. So wait, are you telling me, Miss Lakey, that really the mutual exclusivity addition formula is just this formula, but with a -0 right here? Yep. When two things are mutually exclusive, they have no overlap. So I don't have to worry about that part, and I can just add their two probabilities. But if they're not mutually exclusive, I have to take care of that overlap. Cool? Cool. All right, you guys, are you ready to do a couple of examples? Oh, yeah, you are. You're so excited. How many of you people have a dog? How many of you have a cat? How many of you have both, a dog and a cat? Wow, that's crazy. Here's what I want you guys to notice. Just a moment ago, if I asked you if you had a dog, did you raise your hand even if you did have a cat? Did you raise your hand even if you didn't have a cat? If you had a dog, you did, right? So if you have a dog and you raised your hand, you may or may not also have a cat. So when you read this problem, keep that in mind. In one large city, 40% of all households own a dog, 32% own a cat, and 18% own both. We're going to let D be the households that have a dog. C is going to be the households that have a cat. Hopefully that makes sense. And we're going to create a Venn diagram. Are you ready to do this? I would recommend that you make your circles large. And this is the problem that people have every time. They intersect their circles like that. Don't do that. I can't write anything in there. So make sure that your circles like really overlap. Okay? Make sure you got some overlap that you can write in. All right, which side do you want to be the dog side? That makes sense. So we're going to put dogs over here. We're going to put cats over here. So the dogs are in the left circle. What is the total of this circle supposed to be? 40. Okay? So this whole circle should be 32. And so when you do a Venn diagram, you should start on the inner part and go out. What percent goes here in the middle? That's 18%. 18%. Now, how can I write the statistical notation for that section? D and C. This is D and C. These are people who have a dog and a cat. All right, cool. Now, here's the hard part. What percent goes here? Why 22? Because it's the total of 40 minus this 18 that I've already labeled. So this is 22%. All right, who thinks they know the notation? What is it? D and C complement. Perfect. Perfect. All righty. Let's go over here now. Cat. What is the total amount for the cat circle? 32. How much have I already taken care of? So how much goes here? How much? 14%. What is the notation for that part of the circle? D complement and C. I have a question for you. Can I say that this is C and D complement? Yes, I can. Have I labeled the entire sample space?
No, the outside.
Ah, guys, if I add this up, I don't get 100%. We're missing something.
46%.
D complement and C complement is 40 what? 6%. Now if I add them all up, what do I get? I should now get 100%. All right. Because we have a very well labeled Venn diagram, we can now answer questions. What is the probability that a randomly chosen household owns a dog or a cat? Probability of dog or cat. Dog or cat. Using the formula, that would be the probability of dog plus the probability of cat, but then I would have to subtract the probability of the dog and cat because they are not mutually exclusive. I can have a dog and a cat at the same time. So this would be, what is the probability of having a dog here? 40%. What is the probability of having a cat? 32%. But ouch, you know what I just did there? I just added those people who have both twice. So I need to take off that overlap one time. And what do you get? Now, you get 0.54. Can anybody see a different way to get 0.54? Guys, we could just add up the 22, the 18, and the 14. Cream, sugar, both. I could just add those three up, and don't I get 54? Yes. Sure do. Any other way to do it?
Subtract 46 from 100.
I could just subtract this from the rest, from the 100. Okay? 3 ways to do that problem. Any questions?
Keep it.
No.
It's like not right.
You good? Well, I don't care.
Are you ready?
Oh, I'm so sorry. I didn't realize that.
Now we're going to answer some more questions here. The next question says, what is the probability that a randomly chosen household does not own a cat but does own a dog? Tell me in statistical probability notation what that would look like.
D complementary and C.
So that would. So D complement would be not a dog.
Never mind.
So, do they in this example do they own a dog? They do own a dog. And C complement. Now time out, you guys. Don't you have that exact label in your Venn diagram already? Guess what? This is just the answer right there. Done. There's no math to do because you labeled your Venn diagram so beautifully. What is the probability that a randomly chosen household does not own a dog or a cat? Tell me the notation there.
It's 46.
Wait a second. Time out. Don't you already have that label in your Venn diagram? What is it? Guess what? That's all you have to do to show your work right there. Isn't that awesome?
That is incredible.